students. Today, the topic of discussion is sorting techniques, in which we are going to discuss quicksort. Let's see what is quicksort. Quicksort is actually a very efficient sorting algorithm, and it is based on partitioning of an array of data into smaller arrays. A large array is partitioned into two arrays, one which holds the smaller element than the specified value, which is called pivot, and the other portion is actually holding the greater values than pivot value. Okay, so therefore the array is divided into two parts. Quicksort partitions an array and calls itself recursively twice to store, sort the two resulting subarrays. Definitely, it's a recursive algorithm, and this algorithm is quite efficient for large size data sets. So, large size data sets में हम इसे effectively use कर सकते हैं quicksort. Let's see what are the steps we need to follow while implementing quicksort. सबसे पहला step जो हमें follow करना है, we have to pick an element from array. This element will be called as pivot element. Okay, that is your choice कि आप इसे कौन सा element choose करना चाहते हैं. Generally, first या last element choose कर सकते हैं pivot के लिए. The second step we need to follow is हमें divide करना है unsorted array of elements को two arrays में, with value less than the pivot come in the first subarray, left array, and the elements which are greater than pivot will come in the second subarray, which will be on right hand side. So this particular part or step is called as partition operation, in which we are dividing our array into two parts on the basis of pivot. Okay. The third step we need to follow is we have to recursively repeat the step number 2 until the subarrays are sorted. The above process will be repeated because वो तो सिर्फ partitions को divide कर रहा है, but later on we have to sort the complete list using those partitions. So it will be recursively repeated, and to the subarray of elements with smaller values, and separately to the subarray of elements with greater value. That means दोनों arrays पे separately ये process repeat होगा, and we'll come to get the sorted array. Let's see the example of quicksort, how it works actually. See, this is the list given to us: 54, 26, 93, 17, 77, 31, 44, 55, and 20. What we are going to do is we are actually marking first element as pivot. Let's see, 54 is our pivot element. Okay, and we are marking two pointers. One is a left mark and second one is a right mark. Okay, these are two pointers. What will we do? We will find out that we'll first find out that the element, this 26, is lesser than 54, because lesser elements will be arranged in the left side list, and the greater elements will be arranged in the on the right side list, right? So we'll find out the lesser elements here and the greater elements here. If the element is lesser, then it will remain here only, and if the element is greater, it will move to the right hand side, right part of the list. Okay, and similarly with the right mark, we'll find out the smaller elements in pivot and will shift on the left side. Okay, so what we'll do, we'll find the first greater element on left side, which is 93. We have found it, and on the right mark we have 20. Okay, we have 20. So what we need to do is we have to swap these two elements, because the greater element will be on right side and smaller element will be on left side. So 20 will be shifted here and 93 will be shifted here. Now we'll come to the next position. We'll find out that this is smaller element. This is again smaller element. This is smaller element. This 77 is greater than 54. And the next lesser smaller element on right hand side is 44. Okay, so what we'll do, we'll find out 77 and 44 and we'll swap these two elements as well, because we need smaller elements on the left side and the greater elements on the right side. Okay, so after swapping this, we'll get 44 here and 77 here. After moving to as a left mark, we'll move to the right side, and right mark will move to the left side as soon as we are processing all these things. The next element is 31, which is actually smaller than 54. Okay, so it will come to this list. Okay, so it will come to this list. Fine. And finally 31 will be swapped with 54 and you'll get the element 54 here and 31 at this position. Now the two halves have been sorted, have been arranged. Okay, and we have quick sort left half here and quick sort right half here. Okay, now we'll continue the process of this quick sort till we will get the sorted list. Okay, and as soon as we get the sorted list, the process of quick sort will be complete. Okay, let's see what is the algorithm. I told you in the brief that what we need to perform in quick sort. But let's see now that what algorithm, step-by-step algorithm we need to follow in the quick sort. Okay, the first thing you need to do, step number 1, is choose the lowest index value as pivot. Okay, that means the element on the 0th position will be chosen as pivot. Next step is take two variables to point left and right of the list excluding pivot. Okay, दो variables ले लेंगे हम जो left और right side और list को point करेंगे excluding pivot. Left points to the low index and the right points to the high index, right? And while value at left is less than pivot, move right. Okay, जब तक कि आपकी लेफ्ट साइड की वैल्यू लेसर है pivot से, we have to move to the right side, and from the right side we are finding that the value at right is, while the value at right is greater than the pivot, move left. जब तक कि आपको greater values मिलती जाती हैं, we have to move to the left side. As soon as you get smaller one, only then we'll swap. If both step number 5 and 6 doesn't match, that means आपको ना step number 5 में स्मॉलर वैल्यू नहीं ग्रेटर वैल्यू मिलती है, और स्टेप नंबर 6 में आपको स्मॉलर वैल्यू मिलती है. एट दैट प्लेस विल स्वैप these two values. Okay, and in the last step, if left is greater than equals to right, the point where they met is a new point. Okay, definitely लेफ्ट एक ऐसी पोजिशन सिचुएशन आ जाएगी जब लेफ्ट या तो ग्रेटर होगा राइट से या इक्वल हो जाएगा. एट दैट पॉइंट यू हैव टू स्टॉप द प्रोसेस एंड you have to put the pivot at that place. Okay, so this is the process of quicksort, and this process will be repeated for other two halves as well, so which will be generated after partition. Okay. Let's see what is the time complexity of quicksort. Obviously, there are three cases as in other algorithms: worst case time complexity, best case time complexity, and average case time complexity. Worst case, if I talk about worst case, the worst case time complexity of quicksort is O(n) square. The best case time complexity of uh, quicksort is n log n, and average case time complexity is 2n log n. Okay, but in the worst case, it has become n square. Okay, that's all for quicksort. Thank you very much. Thank you very much for listening.